Today we're going to be going through Edexcel IGCSE January 2023 Chemistry Paper 1C. So let's begin. Here we have the periodic table, so they give that to you at the beginning of every test. Okay, this question is about the three states of matter, solid, liquid and gas. The diagram shows how particles of a substance are arranged in two of these states. Complete the diagram to show how particles are arranged in the liquid state. So I've already done that for you guys. The two main things you need to remember if the particles are arranged in the liquid state is that they're very irregularly arranged and the particles must touch each other, okay? So in a solid, you can clearly see that the arrangement is very regular. All the particles, they're in neat rows. But in liquid, the particles are irregularly arranged and they're touching each other. In a gas, they're very far apart and there's a random arrangement, okay? So those are the main things you need to remember. Identify the state of matter that contains particles with the least energy. This is going to be a solid. Why? Because in gases, the particles, they have lots of kinetic energy, okay? They're moving very randomly, they're moving rapidly, and they're very far apart from each other. Whereas in a solid, the particles are vibrating on their axes, and that means they have very little energy, okay? They've got the least energy. And as you can see, the particles are very close to each other, so they don't have much room to vibrate, and therefore they have the least energy. Next, the table shows two changes of state. Complete the table by giving the name of each change of state. So from a solid to liquid, you're going to be melting. Okay, you melt the solid to get a liquid. And then from solid to gas, that's sublimation. Okay, these are just processes that you have to learn. Next, explain why hot water evaporates more quickly than cold water. Okay, so hot water and cold water. If you think about it, in hot water, you've got the temperature of the water is going to be much higher. And what does this mean for the particles? Well, if the temperature is higher, that means the particles in hot water, they have much more kinetic energy. Okay, and what this means is that the particles are going to be moving much faster in hot water than in cold water, because if they have more kinetic energy, they're going to move more rapidly and faster. And what this means is that the intermolecular forces between the water molecules are easily overcome. Okay, so if the particles, they're moving very rapidly, the forces are going to become weaker and eventually they'll become overcome. So this means that if the water is hot, it means that the intermolecular forces between water molecules are overcome. And as a result, the water molecules can evaporate. So evaporation is when the water molecules have sufficient kinetic energy to leave the liquid. And that is more likely to happen in hot water than in cold water due to the particles having enough kinetic energy and being able to overcome those intermolecular forces that are keeping them in that liquid state. Okay, next question. This question is about elements, mixtures and compounds. Which of these is the formula of a molecule of an element? Okay, so oxygen exists as O2, not as O. So that's just an atom and it's not the formula of a molecule. So it can't be A. B, chlorine. Yes, that's correct because Cl2 is how chlorine exists and it's a molecule. HCl is a compound. Okay, that's a compound. And H2O is also a compound. So the answer is going to be B. Next question. Which method can be used to separate an insoluble solid from a liquid? Okay, so if you have an insoluble solid and you want to separate it from a liquid, the best way to do this is filtration. Because then you have if I draw a quick sketch here. Okay, that's my filter paper. You've got your solid, which is stuck here. That's your solid. And then the liquid drains out through the funnel and ends up as a residue. Okay, so that's your insoluble solid and that's the liquid. So C is the best answer. Crystallization is used to separate soluble solids from solvent. And how you do that is by evaporating the solvent and you're left with that soluble solid. So it's not applicable for this. Evaporation is very similar. you're trying to separate a solid from a solvent and you evaporate the solvent. Simple distillation you use to separate liquids. Okay, so the best answer is C. Next, give the name of a method used to separate a mixture of liquids with different boiling points. This method is called fractional distillation. Okay, so fractional distillation is the process by which you separate liquids, a mixture of liquids with different boiling points. So you have the glass beads and the molecules with the most kinetic energy, they evaporate and they enter the fractionating column and are collected. Okay, and in this process you can separate all the liquids. Okay, so you can obtain each liquid one by one. And the boiling and the liquids must have different boiling points so that they evaporate from the liquid that has the lowest boiling point to the liquid that has the highest boiling point. Next question. A student adds a crystal of substance X to some water in a beaker and leaves the beaker for 1 day. The diagram shows the beaker immediately after adding the crystal and after 1 day. Okay, so as you can see here, we've got the solid or the crystal, but now it's disappeared. So what must have happened is that the crystal must have dissolved in the water. Okay, it must have dissolved. And now you can't see the crystal because it's dissolved in the water. Okay, let's read the question. Which equation gives the correct state symbols for the process that occurs in the beaker? Okay, so the crystal is obviously starting off as a solid, so it's not going to be C. It can't be C. But now, as I mentioned before, the crystal's dissolving in the water. So when a substance dissolves in a solvent or in some water, it becomes aqueous. Okay, so the correct answer would be D. It's starting off as a solid and then it's dissolving in some water, which is why it turns aqueous. Next question. Which other process occurs in the beaker? Boiling, condensing, diffusion, sublimation. It's going to be diffusion. And the reason why is because if you have a crystal and it's dissolved in the water, some of the particles around the crystal, actually, when they dissolve, there's going to be a high concentration of crystal particles here. And there's going to be a low concentration, for example, up here. Low concentration. So that means diffusion is going to take place. Diffusion is the movement of molecules from an area of high concentration to an area of low concentration. So diffusion is the correct answer. It's not boiling because you're not heating anything and you're not changing from liquid to a gas. It's not condensing either because you're not changing from gas to liquid, and it's not sublimation because you're not changing from solid to gas. There's no state changes. Okay. After 1 day, the student does 2 tests on the liquid and the beaker. The table shows the student's results. Identify substance X. Okay. So flame tests, you must familiarize yourself with them. There's quite a few to learn. But if it's a lilac flame, it means that the metal is potassium. Okay. Potassium gives you a lilac flame. And the anion is going to be sulfate. Okay, so the flame test for sulfate ions is you add hydrochloric acid and then you add acidified barium chloride solution. And if sulfate ions are present, there'll be a white precipitate that's formed. So substance X is going to be potassium sulfate. Potassium produces that lilac flame, and sulfate ions give you that white precipitate when you add acidified barium chloride. Okay, next question. This question is about gases. Name the gas that is about 1% of dry air by volume. So that's going to be argon. Argon occupies approximately 1% of air. What is the most abundant gas in dry air by volume? That's nitrogen. So nitrogen is approximately 78% of air. Okay, oxygen is approximately 21%. And then these occupy very little portions. Carbon dioxide about 0.04%. So nitrogen is the most abundant. A student uses this apparatus to find the percentage by volume of oxygen in a mixture of oxygen and neon. This is the student's method. Measure the initial length of the column of gas in the inverted test tube, leave the test tube in the beaker for a week, and measure the final length of the column of gas in the test tube. Some of the iron will rust. Give the name for rust, the chemical name. Okay, so iron, in order to rust, you need 2 things. You need oxygen, Okay, and you need water. That way, iron will begin to rust, and the chemical name for rust is hydrated iron 3 oxide. This is just something you have to learn. Okay, hydrated iron 3 oxide. Give a reason why neon does not react with the iron wall. Okay, so neon, you have to remember, it's in group 0, group 8, okay? So that means if you draw the electronic configuration, or if you write the electronic configuration of neon, it's 2.8. So that means it has a full outer shell, which means that it's inert, it's unreactive. So the real reason why neon does not react with the iron wall is because neon has a full outer shell. Of electrons, and therefore it won't donate or it won't gain any electrons because it already has 8 electrons in the outer shell, which is the maximum number of electrons it can hold. The table shows the students' results. Use the results to calculate the percentage of oxygen in the mixture of oxygen and neon. So what they're given to us is the initial length of column of gas and the final length of column of gas. So it starts off at 75 centimeters. And then it goes down to 30 centimeters. Now, remember what I said earlier is that in order for iron to rust, it will only react with the oxygen, okay? It will only react with the oxygen. So the neon is irrelevant here. So the fact that the column of air decreases from 75 millimeters to 30 millimeters suggests that the iron has reacted with all the oxygen, okay? So the difference in this, the difference in this length is the volume of oxygen it's reacted with. So we can begin by finding the difference in length. So the difference in length will be 75 minus 30, which is 45 millimeters. Okay? Now, use it to calculate the percentage of oxygen in the mixture of oxygen and neon. So if 45 millimeters was the volume of oxygen it reacted with and the initial length was 75 millimeters, that's going to be, multiply that by 100, that will give you the percentage of oxygen in the mixture of oxygen and neon, okay? Because it's reacted with this, okay? That's the volume of oxygen it's reacted with. This is the initial volume of everything. And if you multiply by 100, it will give you the percentage of oxygen. So let's quickly calculate that. That will give you an answer of 60%. Okay? Cool. Next question. A student uses this apparatus to investigate the dyes in the food colouring A. Explain 2 mistakes that the student makes when setting up the apparatus. Okay, well, clearly, we can already identify the 2 mistakes. First of all, this baseline is drawn in ink, okay? It should not be drawn in ink because what will happen is that it will contaminate the result. It will interfere. Because say that you have a dye here, okay, which they've drawn, the dye. The ink will mix with that dye and it will affect the results. It will affect how far the dye moves up the chromatography paper. So what the student should have done is drawn the baseline in pencil. So let's see, 2 mistakes that the student makes. So the baseline has been drawn in ink. That's a mistake. And as a result, the ink will mix with the dye and contaminate the results, okay? So that's one problem. Now the second problem is that the baseline here is clearly under the water, and that's going to be a problem because now this dye and the baseline is going to be dissolving in the water. It's going to dissolve in the water. Okay? So normally when you do chromatography, you have to make sure that the baseline is above the water so that it doesn't dissolve before the experiment starts. So that's another mistake that the student has made. The baseline is below water level. So A will dissolve, so dye A will dissolve in the water. Okay, next question. The student repeats the experiment but with no mistakes. The table shows the RF values for the two dyes in food colouring A. Complete the chromatogram for food colouring A by adding and labelling the dyes. Okay, so they've given us the RF value for blue and yellow. What is the RF value? So the RF value is the distance moved by substance divided by the distance moved by solute. Okay, so clearly from the results that they've given us, we can see that blue has a higher RF value than yellow. So blue is has an RF value of 0.5, which means it's approximately halfway up between the baseline and the top of the paper. And yellow is approximately a quarter of the way up. So I'm just going to estimate this. If I draw blue, so blue is approximately halfway up, so I'm going to say it's about here. Okay, and yellow is approximately a quarter of the way up, so I'm going to say it's about here. And make sure to label the spots because it says label the dyes. So that's yellow, and that's blue. Okay, cool. Next question. Give a reason why the blue dye has a larger RF value than the yellow dye. So RF value, it really depends on the solubility of the dye. Okay, it really depends on the solubility of the dye. So if the blue dye has a larger RF value, what this means is that the blue dye is more soluble in water. The blue dye is more soluble in water, and as a result, it moves further up the chromatogram compared to the yellow dye. Okay, so another common question that comes up often is, what will you do if, for example, dye A doesn't move up the chromatogram? What you can do is just switch the solvent, because dye A might be soluble in ethanol. Okay, so there's a wide range of solvents you can use. Water is the common one, but ethanol is also another one that you can use. So if they ask you what you can do, if dye A does not dissolve, you can just say you'll switch the solvent, use another solvent, for example, ethanol. Okay, cool. Next question. A student investigates the reactivities of 4 metals: aluminium, magnesium, copper, and metal X. The student adds pieces of magnesium ribbon to aqueous solutions of the sulfates of each metal. After a few minutes, the student removes the pieces of magnesium ribbon and records the appearance of each piece of magnesium. Table 1 shows the student's results. Okay. Name the substance that causes the brown coating on magnesium. Let's see. Okay, so brown coating on magnesium. So we have copper 2 sulfate then. So what is happening is that magnesium is being added to copper 2 sulfate, and a reaction is clearly occurring because there's a brown coating. So let's see what will be formed. Since magnesium is more reactive than copper, it's going to displace copper from its compound, and this is a displacement reaction. So what's going to form is magnesium sulfate plus copper. Now the question's asking what causes the brown coating on the magnesium. Copper is brown, so the substance that causes the brown coating is copper. Okay, so for these questions I recommend writing a word equation. It's much easier to identify which substance then. State why there is no change with magnesium sulfate solution. Now, remember that magnesium is being added to all of these, okay? Magnesium is being added. Now, if you add magnesium to magnesium sulfate, nothing's going to happen because magnesium can't displace itself. They both have the exact same, they're both exact same elements, so they can't displace one another. So a displacement reaction can't take place. So why is there no change? Because magnesium cannot displace itself. Remember, they're exactly the same element, so one is not going to displace another element here. Cool. The student repeats the experiment with pieces of metal X instead of pieces of magnesium. Table 2 shows the student's results. Use the information from both tables to deduce the order of reactivity of aluminium, magnesium, copper, and metal X. Now, Okay, it says here to use the information from both tables, okay? So, I mean, you could use, if you know the reactivity series off by heart, you could use it. But remember, the problem here is you don't know what metal X is, so you don't know where it's going to fall. So it's better just to use the observations that the student has made. So you can see here, let's start off by what's the most reactive. Well, magnesium, if we look at it, has no change. It has no change when metal X is added, and it also has no change when magnesium is added. Okay. So what that means is that if there's no change, that means that there's clearly no displacement reaction taking place. So magnesium must be more reactive than the magnesium metal that's been added, and also metal X. So that means magnesium is going to be the most reactive. Oops. Sorry. Magnesium. Okay. Let me just explain that again one more time. You can see here, magnesium in both table 1 and table 2 is the only metal that has no change, okay, in both reactions. And that can only happen because magnesium is more reactive than the substance that's being added, and therefore magnesium must be the most reactive element. Now let's see what would be the next reactive. If we look at aluminium here, aluminium has no change in reaction 2, but it has a change in reaction 1. Now, if you compare the other elements, copper and metal X, they have a... Actually... Yeah. Okay, if you compare copper, you can see that there's a reaction in both table 1 and table 2. So copper forms a brown coating on magnesium, and in the second reaction, there's a brown coating on metal X. So that means copper must be the least reactive. Okay? Because it's reacted in both reactions. It's been displaced in both reactions, so it must be least reactive. Now we have aluminium and metal X left. Aluminium, it doesn't change in reaction 2, but it changes in reaction 1. And what this shows is that aluminium is going to be the next most reactive. Why? Because aluminium is more reactive than metal X. Okay, we've got aluminium and metal X left. We can just use table 2 even to deduce the order of reactivity. We've got aluminium and metal X, and aluminium has no change. Okay, so clearly aluminium is more reactive than metal X because it can't be displaced by metal X. Oops, spelling is not very good here. Aluminium, and this has to be metal X. Okay, cool. Give a possible identity for metal X. So this does involve you knowing your reactivity series. Between aluminium and copper, there's zinc, iron, tin, lead. Okay, those are the 4 metals. Zinc, iron, tin, lead. So you can choose any of these metals. I'm going to go with iron. So iron is less reactive than aluminium, but it's more reactive than copper. So it could be metal X. This ionic equation represents the reaction between magnesium and aluminium nitrate. Explain in terms of electrons which species acts as a reducing agent in this reaction. Okay, so what you need to remember is, if a species is acting as a reducing agent, it means that it's being oxidized itself, okay? So if something is being reduced, it means that it's oxidized itself. And what oxidation means, okay, I hope you guys know this acronym, oil rig. Oxidation is loss of electrons, hydrogen, and rig, reduction, is gain of electrons and hydrogen. Now, if the substance is being oxidized, that means it's losing electrons. And if we see in this ionic equation, magnesium is going from Mg to Mg2+, so it's lost electrons. So clearly, magnesium is the reducing agent, because it is getting oxidized. Now, we have to explain this in terms of electrons, as it says in the question. So you have to make sure you include that. Magnesium, what it's doing is it's losing electrons, but what's happening to the electrons? It's donating it to aluminium. So the reason why it's getting oxidized is because magnesium loses electrons and donates this to aluminium, and as a result it is acting as a reducing agent. Okay, it's reducing aluminium, but itself is getting oxidized. Okay, cool. Next question. This question is about polymers. This is the structure of a monomer. What is the name of this monomer? Now, as you can see, there's a double bond, so it's going to be an alkene. It can't be chloroethane, so it's not A, and it can't be C either. And there's only 2 carbons, so propene has 3 carbons, so it can't be D. It must be chloroethene. It's chloro because of the Cl, and then ethene because it's an alkene with 2 carbons. Complete the equation to show the repeat unit of the polymer that forms from this monomer. So what you do is you break that double bond, and that extends outside the bracket. Okay, this is going to be the repeating monomer, and then you just copy out the atoms. Hydrogen, hydrogen, and chlorine. Okay, next question. A typical molecule of this polymer has a relative molecular mass of 2,490,000. Show that the number of monomer molecules needed to make this typical molecule is about 40,000. Okay, so let us first work out the molecular mass of chloroethane. Chloroethene, okay? Because once you work out the molecular mass of one repeating unit, you can divide it by the MR of the whole polymer and work out how many monomer molecules are used, okay? So the MR of chloroethene will be, so the structure is here. So there's 2 carbon atoms, 2 times 12, 3 hydrogen atoms, 1, 2, 3, and 1 chlorine atom, 35.5. So if we do the maths for that, let me quickly work that out. 24 plus 3 plus 35.5. That should give you an answer of 62.5. Okay, so the MR of one chloroethene molecule is 62.5. Now, the whole polymer itself has a MR of 2,490,000. So if you divide that, 2,490,000 divided by 62.5, you'll get the number of monomer molecules in that polymer. And that will give you an answer of 39,840, which is approximately 40,000. Okay? Next question. There are 2 methods used to dispose of the polymer: burying in landfill sites, and burning. Discuss the environmental problems caused by these 2 methods of disposal. Okay. Well, burying in landfill sites is a huge problem. First of all, polymers itself. Let's talk about what's wrong with polymers. Why can't we just dispose them easily? Because polymers, they're inert, okay? I'm going to write in bullet points, and in the exam you guys can write in bullet points, okay, as long as you mention all the points you need. So polymers, they're inert, and therefore they're non-biodegradable. So what that means is that they can't be broken down by bacteria, so they just accumulate. So when you bury them in landfill sites, what happens is that they will remain in landfill sites for a long time because they can't be broken down. So they just accumulate, and eventually this causes space to run out. Okay? Because obviously there's only a limited amount of space. So that's a huge problem with burying in landfill sites. Now, for burning, the problem is that when you burn polymers, toxic gases are being released. And it also produces greenhouse gases like CO2 when you burn polymers. and this will contribute to global warming, which is not very good. So those are two environmental problems caused by disposing polymer. Okay, so those are the main reasons. You just need to remember that polymers, they're inert, so that'll give you a mark. And they remain in landfill sites for a long time because they can't be broken down. So they just accumulate and space will run out. That's another mark. Burning polymers, it leads to toxic gases being released. That's one mark. And it produces greenhouse gases like CO2, which contributes to global warming. So that's another mark. Okay. A different polymer molecule contains 10,600 atoms of carbon, 10,600 atoms of hydrogen, and 31,800 atoms of chlorine. Determine the empirical formula of this polymer. So the empirical formula is the simplest whole number ratio of atoms of each element in a compound. So to determine the empirical formula, what we are going to do is write down the number of atoms and you divide it by the least number of atoms. So 10,600 is the smallest number of atoms. So you divide everything by 10,600 and then you'll get your empirical formula. So that'll give you 1, 1, and 3. So the empirical formula is going to be CHCl3. Okay? Next question. The table shows the displayed formulae of some organic compounds. Give a reason why X is not a hydrocarbon. Okay, so this is also another common question. They ask you what is the definition of a hydrocarbon. Hydrocarbons, they're compounds with only hydrogen and carbon atoms. Okay, so if we look at compound X, we can clearly see there's an oxygen atom, which is why it's not a hydrocarbon. So X contains oxygen, therefore not a hydrocarbon. Okay, next question. Give the letter of the compound that is a saturated hydrocarbon with the empirical formula CH2. Okay, so if we work out the empirical formula of some of these compounds, so that's 1, 2, 3, 4, 5, 6, 7, 8. C8H 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that empirical formula, if we simplify it, it will be C4H9, which isn't CH2. Now let's look at this. There's C4 and 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. If you simplify that, that's CH2. So that's going to be W then. And it's a saturated hydrocarbon. We have to check that. If it's a hydrocarbon, it only contains hydrogen and carbon atoms. Yep. And if it's saturated, it only contains carbon-to-carbon single bonds. Yeah. So W is correct. Okay, next question. Give the letter of the compound that produces 9 moles of water when 1 mole undergoes complete combustion. Okay, so when it reacts with oxygen, it should produce 9 moles of water. So if we write the chemical equation for some of these compounds, if we start off with V, C8H18 reacting with oxygen. So whenever a hydrocarbon reacts with oxygen, it always produces carbon dioxide plus water. And if we balance this, there's 8 carbons here, 8 carbons here, 18 hydrogens. So if we add 9 here, there'll be 18 hydrogens. And then 16 plus 9, 25 oxygens, so 25 over 2. Now, does this produce 9 moles of water? Yeah. So the answer is going to be V. V. Give the structural formula of compound Y. So what they mean by structural formula is how the atoms are attached to each other, how they're connected, okay? So the structural formula of compound Y is going to be CH2, because we have a carbon with 2 hydrogen, then CH, we've got the carbon with 1 hydrogen, and then CH2, a carbon with 2 hydrogens, and CH3, carbon with 3 hydrogens. So that's the structural formula of compound Y. It just shows how the molecules are attached to one another, how they're arranged together. Okay? Explain why compounds W and Y are isomers. So what does isomers mean? Isomers is when compounds have the same molecular formula but different structural formula. So as you can see, compound W has a molecular formula of C4H8 and compound Y has a molecular formula of C4H1234567 Okay, so they have the same molecular formula, but you can clearly see that they have different structures, which is why they're isomers, okay? So this is another definition you need to know off by heart. They're isomers because they have the same molecular formula but different structural formula. Okay? And this is also a very common question in the organic section. Next. Compound Z reacts with bromine in the presence of ultraviolet radiation. So whenever you see the word ultraviolet radiation, you have to immediately think of substitution reaction, okay? Substitution reaction, because that's the only reaction that requires UV light, and this only happens for alkanes, okay? Only alkanes can undergo substitution reactions. Write a chemical equation for this reaction. So let's find the formula of compound Z, C4H12345678910, C4H10. So compound Z, which has a formula of C4H10, reacts with bromine. Bromine is diatomic, and it undergoes a substitution reaction. So what happens is one of the hydrogens, okay, it's substituted for a bromine atom. So it becomes C4H9Br, and the hydrogen combines with the remaining bromine atom. So that's going to be the equation. What is the name for this type of reaction? It's substitution. Actually, let me show you let me just run through the substitution really quickly, because it might help you understand it if you see a diagram. Okay, so I'm going to react methane with bromine, okay? Now, if we draw a displayed formula of methane and bromine, what happens is this bromine atom, it replaces one of the hydrogens. So I'm going to pretend that it replaces this hydrogen atom, okay? So it replaces this hydrogen atom, and what we form is the bromine comes here, but now that hydrogen is just free, okay? The hydrogen is being removed from this methane, and it will combine, this hydrogen combines with this bromine here, and we form HBr, okay? So now, if we react butane, that's C4H10, butane, with bromine, one of the hydrogens removed and replaced with a bromine, and you form HBr, okay? Cool. Describe how the combustion of sulfur-free petrol in a car engine produces gases that can cause acid rain. Do not refer to carbon dioxide in your answer. Okay, make sure you read the question, because lots of people can fall for this trap. Sulfur-free, that means sulfur is not being burnt here, and it's not going to cause acid rain. It's another gas. Now we need to identify what gas is being burnt in car engines, and the two main gases normally are nitrogen and sulfur. It says sulfur-free, so it's not going to be sulfur, so it's going to be nitrogen. Nitrogen reacts with oxygen in the car engine, and it reacts at very high temperature and pressure. At high temperature and pressure. Okay, now when nitrogen reacts with oxygen at high temperature and pressure, it produces oxides of nitrogen. Oxides of nitrogen form. And some examples will be nitrogen dioxide or nitric oxide. Okay, those are some examples. And what happens is, these oxides of nitrogen, so for example, nitrogen dioxide, oxides of nitrogen, they react with water. They react with water, and as a result, you form acid rain. And what is acid rain? What happens when nitric oxides react with water? You form nitric acid, which is a component of acid rain. Okay, so make sure you read the question. It says sulfur free. So for example, if they said sulfur instead, okay, say that sulfur is burning in car engines. Sulfur, it reacts with the oxygen in car engines to form sulfur dioxide or sulfur trioxide, and that will react with water to form sulfuric acid or sulfurous acid, which is also a component of acid rain. But you have to be careful because there's no sulfur in this petrol. So it's only going to be nitrogen that's reacting. Okay, next question. This question is about ionic compounds. The table gives the formulae of some positive and negative ions and the formulae of some compounds containing these ions. Complete the table. Okay, so this should be easy. You've got Na plus and Cl minus. You just swap the charges and you form NaCl. Okay, so if you're struggling with ionic formulae, you can see that Na plus and Cl minus, this will have a 1 in front of it. And what you do is you swap the charges, okay? So Na, that should be 1 here, and Cl, 1. But that would just give you NaCl. Now if we do the same for Mg2 plus and Cl minus, Mg2 plus, Cl minus, these swap, okay? So you get Mg1, you don't include the 1, and then Cl2. So that'll be MgCl2. Same for magnesium nitrite. Magnesium nitride. Okay, so you swap it. Mg, now that will get 3 and N2. So the formula is going to be Mg3N2. Let's move on. Give the name of the compound with the formula MgO. That's going to be magnesium, and that's oxide. So the name is magnesium oxide. Calculate the relative formula mass of Na3N. Okay, so if they want you to work out the relative formula mass, what you do is you just add the relative atomic mass of each element. So here we've got 3 sodium, so it's going to be 3 times 23, because the relative atomic mass of sodium is 23, plus 1 nitrogen atom, 14. And that should give you an answer of, let me work it out quickly, 83. Okay, so MR is 83. Next question. The diagram shows the arrangement of electrons in atoms of lithium and in an atom of oxygen. Describe the changes in the electronic configurations of lithium and oxygen when these atoms form lithium oxide, Li2O. Okay, so it says to describe the changes in the electronic configurations. Okay, so let's work out the initial electronic configurations and then the final electronic configuration. So for lithium, it's going to be 2.1 because you've got 2 electrons in the inner shell and then 1 electron in the outer shell. And for oxygen, it's going to be 2.6. Now, when lithium oxide is formed, remember the whole point of compounds, of elements forming ionic compounds, is that they want to get a full outer shell. So you want to achieve either 8 electrons in the outer shell or 2 electrons in the outer shell. So lithium, what happens is it donates these electrons to oxygen. It donates it to oxygen. And now oxygen, it gains those 2 electrons. So lithium atom, it changes from 2.1 to just 2, the electronic configuration, because it's donated that electron to oxygen. And oxygen atom, it gains 2 electrons, so it goes to 2.8. So let's just write that out. Lithium changes from 2.1 to 2, and oxygen changes from 2.6 to 2.8. Okay, it's gained those 2 electrons, one from each lithium atom. Lithium oxide has a giant ionic structure. Explain why lithium oxide has a high melting point. Okay, so it has a giant ionic structure. And what does that mean? It means that there's ionic bonds. Okay, there's lots of ionic bonds. Now, for these type of structure questions and why something has a high melting point and why it can conduct electricity, you need to make sure you're very comfortable with it, because it is a very popular question that comes up in lots of papers. So, if you have lithium oxide, let's start off by saying lithium oxide has a giant ionic lattice structure. Okay, so that means that there are strong electrostatic forces of attraction. Electrostatic forces of attraction between oppositely charged ions. Okay, so if something has, so you have to remember the definition of ionic bonds. So ionic bonds is the strong electrostatic forces of attraction between oppositely charged ions. So if lithium oxide has a giant ionic structure, it means that there's lots of strong electrostatic forces of attraction between the oppositely charged ions, and therefore you need lots of energy to overcome these forces of attraction or break the ionic bonds. Okay, ionic bonds, they're so strong, they're very, very strong, so you need lots of energy to overcome these electrostatic forces of attraction, which is why lithium oxide has a high melting point. So lots of energy required to overcome these strong electrostatic forces of attraction, and therefore lithium oxide has a high melting point. Okay, next question. This question is about the substances that contain covalent bonds. The diagram represents a molecule of oxygen. Describe the force of attraction in a covalent bond. So this is just basically asking the definition of a covalent bond. I need to learn this. Covalent bond is the strong electrostatic force of attraction between two positively charged nuclei and a shared pair of electrons, okay, which is what covalent bonds are about. Okay, it's when atoms share electrons to form molecules. You can see that here. Those are the shared electrons. The table shows the boiling points of these group 7 elements. Explain the trend in the boiling points. Okay, so you can clearly see from fluorine to bromine, the boiling point increases. Okay, the boiling point is increasing. Now you have to think about why. What is boiling point got to do? What is it about? It's got to do with the intermolecular forces of attraction between the molecules. So somehow from fluorine to bromine, the boiling point is increasing, and that's because the intermolecular forces of attraction are becoming stronger. So that means more energy is required to overcome these intermolecular forces of attraction. But why? Why are they becoming stronger from fluorine to bromine? Now, if you think about it, fluorine is F2, okay? And if we work out the molecular mass, it will be 38. And bromine is Br2. If we work out the molecular mass, it's 160. Now, bromine has more electrons than fluorine. So the greater number of electrons you have, the stronger the intermolecular force of attraction, and therefore more energy is required to overcome those intermolecular forces and separate those molecules, and therefore the boiling point increases. So that's the answer. Okay, so let's write that down. Boiling point, BP stands for boiling point. Boiling point increases from fluorine to bromine because intermolecular forces get stronger, okay? And the reason why they get stronger is because the number of electrons increases from fluorine to bromine, and therefore more energy is required to overcome the intermolecular forces. between the molecules. And therefore, as a result, bromine has a much higher boiling point than fluorine. Okay, next question. Graphite is a naturally occurring form of carbon. Explain why graphite is soft and conducts electricity. Okay, so there's 2 parts to this question and it's 5 marks. Refer to structure and bonding in your answer. Okay, so let's do this step by step. Let's first talk about the structure of graphite. What is graphite? Now, graphite is a giant covalent lattice, or giant covalent network structure. Okay? Now, why is graphite soft? Graphite's soft because graphite is arranged in layers. Okay, so you've got hexagonal sheets. Let me just draw a quick structure diagram so it'll help you understand. Okay. These are supposed to be hexagons, by the way. Okay, so you've got hexagonal sheets and you've got weak forces of attraction, weak intermolecular forces of attraction between the layers. So you've got hexagonal sheets which are arranged in layers, and there's weak forces of attraction between the layers. Now, because the intermolecular forces of attraction between those layers are very weak, it means that they can easily be overcome and the layers can slide over each other, which is what makes graphite soft. Now, why does it conduct electricity? Because each carbon atom in graphite, if I draw out one hexagonal shape, each carbon atom is bonded to 3 other carbon atoms, okay? So the problem with graphite is that since each carbon atom is bonded to 3 other carbon atoms, it means that there's a free delocalized electron per carbon atom. Okay, there's 3 delocalized electrons and they can easily move throughout the lattice structure to conduct electricity. So that's basically your answer. So graphite is a giant covalent network structure, but it's arranged in layers. It's arranged in layers why my pen's glitching. Arranged in layers, and there are weak intermolecular forces of attraction between the layers. And as a result, because they're very weak, the intermolecular forces can be easily overcome and the layers can slide past each other. And since the layers can slide past each other, it means that graphite is soft, okay? That means that graphite is very soft. Now, why does it conduct electricity? Because each carbon atom is only bonded to 3 other carbon atoms. And remember that carbon can make a maximum of 4 bonds. Okay, so carbon can make a maximum of 4 bonds, but in graphite it's only bonded to 3 other carbon atoms. So as a result, each carbon atom has a free delocalized electron. And these delocalized electrons, they can easily move throughout the lattice structure to conduct electricity. Okay, so that's basically it. That'll get you your 5 marks. Okay, and we've mentioned structure and bonding. We've mentioned that's arranged in layers and has a giant covalent network structure. And we've mentioned bonding because it makes covalent bonds, okay, the giant covalent networks. And we can also say here, each carbon atom is only bonded to 3 other carbon atoms with strong covalent bonds. Okay, just to emphasize that there's covalent bonds. But we can also show that there's intermolecular forces between the layers. Okay. a student uses this apparatus to record the maximum temperature in this reaction between solutions of hydrochloric acid and sodium hydroxide. This is the student's method. Add 25 centimeters of hydrochloric acid to the beaker, add 25 centimeters of sodium hydroxide solution to the beaker, stir the mixture, record the maximum temperature reached. Name a suitable piece of apparatus to add 25 centimeter cubes of solution to the beaker. Okay, so a suitable apparatus, if you're measuring 25 centimeter cube, you normally use measuring cylinders. Okay, measuring cylinders are quite accurate and it's the most common apparatus to measure small volumes. So it's a measuring cylinder. Okay. Before this reaction, both solutions have a temperature of 21 degrees Celsius. The heat energy change for this reaction is 2,880 joules. Calculate the theoretical maximum temperature reached by the mixture, which has a mass of 50 grams, and they've given us the specific heat capacity. Okay, so for these enthalpy change questions, you have to remember the formula. You have to learn this formula. Q, which is heat energy release, equals mc delta T. So m is the mass of, in this case, it's going to be the mass of the mass of the mixture, which is 50 grams, so the mass of the acid and the alkali. C is the specific heat capacity, and delta T is the temperature change. So what we're going to do here is we're going to plug in the values and we're going to work out what delta T is, what the temperature change is. Once we've worked out what the temperature change is, since we have the initial temperature already, we can use the temperature change to find the maximum temperature reached, which is basically the final temperature. Okay, so let's do it. Q is 2,880, M is 50, C is 4.2, and delta T is what we need to work out. So delta T equals 2,880 divided by 50 multiplied by 4.2. So delta T should give you an answer of 13.71 degrees Celsius. Okay? Now, that gives you the temperature change, but remember the question's asking what's the maximum temperature reached by the mixture. So if the temperature of the original solution was 21 degrees Celsius and the temperature change was 13.71 degrees Celsius, the final temperature should be those added together, which is 34.7 degrees Celsius to 3SF. So 34.7. Okay. Give a reason why the maximum temperature recorded by the student is lower than the theoretical maximum temperature calculated. Okay, so this is such a common question, and there's literally the same answer that repeats through all the papers. It's the fact that some of the heat energy is lost to the surroundings. Okay, so the reason why the temperature change isn't as high as we calculated is because in reality it's not going to be an ideal experiment, and some of the heat energy is going to be lost to the surroundings. Okay, so that's the answer. Some heat energy is lost to the surroundings. Next, in this reaction, 0.05 moles of hydrochloric acid completely react. Calculate the molar enthalpy change delta H in kilojoules per mole of hydrochloric acid. Include a sign. Okay. So when you work out the enthalpy change, this is another formula you need to remember. Delta H equals Q divided by moles. Okay, Q is going to be in kilojoules, and they've said the units is kilojoules. So they've given us Q at the beginning. It was 2,880 joules, the heat energy change. But remember, we need to convert it into kilojoules. So we have to divide by 1,000. 2,880 divided by 1,000, which will give you an answer of 2.88. Divide by the moles. They've told us that 0.05 moles of hydrochloric acid react. So you divide by 0.05. That gives you an answer of 57.6. But you have to be very careful here. It says include a sign in your answer. This is something very common that lots of people forget. Include a sign because delta H, it can either be exothermic or endothermic. Now, we have to remember that the temperature is rising. The temperature is increasing here. Okay. It starts off at 21 degrees Celsius and is increasing to 34.7 degrees Celsius. So because the temperature is increasing, it means that heat energy is being released into the surroundings, so it's an exothermic reaction. So the sign should be minus. So the enthalpy change will be minus 57.6 kilojoules per mole. Okay. This question is about the reaction between magnesium and dilute nitric acid. The student reacts dilute nitric acid with an excess of magnesium powder as a first step in the preparation of dry crystals of hydrated magnesium nitrate. This is the equation for the reaction. Explain why it's important that magnesium is in excess. Okay. Now, magnesium has to be in excess because if you think about it, the whole purpose of this experiment is that you want dry crystals of hydrated magnesium nitrate. So you only want magnesium nitrate in the final product, okay? Now, if you have nitric acid in there, because they're both got the same state symbols, they're both aqueous, they're going to mix together and you're not going to get pure magnesium nitrate, which is what you want as a product. So you need magnesium in excess to make sure that there's no nitric acid and make sure that all the nitric acid has reacted. Okay, so you want excess magnesium to make sure all the nitric acid has reacted, and as a result, in the products, you will only have magnesium nitrate. Therefore, the products or the solution contains only magnesium nitrate, because otherwise, if you didn't fully react it, there will also be nitric acid in the solution. Okay, next question. The student adds 0.75 grams of magnesium to 0.025 moles of nitric acid. Calculate the mass of magnesium in grams that remains at the end of the reaction. Okay, so remember at the beginning of the question, they told us that magnesium is in excess, okay? They've told us here magnesium is in excess. So whenever you do these types of questions where you're working out how much is left of a reactant, you have to make sure you use the limiting reactant because that is what's limiting the whole reaction. So we've got 0.75 grams of magnesium and we've got 0.025 moles of nitric acid. Now we have to use 0.025 moles of nitric acid because that's the limiting reagent. That's the limiting reagent. Now, if we've got the moles of nitric acid is 0.025 moles, the moles of magnesium that reacts then will be half of that because as you can see the ratio of magnesium to nitric acid is 1 to 2, okay, 1 to 2 ratio. So if we have 0.025 moles of nitric acid, you have to half that to work out the moles of magnesium that are reacting. And that would be 0.0125 mole. Now you can work out the mass of magnesium that reacts by doing moles times mR, okay? Because you know moles equals mass divided by mR. That's a formula you have to learn. Now the moles of magnesium reacting is 0.0125 and the mR of magnesium is 24. Sorry, the AR, because it's an atom. And that will give you a mass of 0.3 gram that reacts. So it says calculate the mass of magnesium that remains at the end of the reaction. We start off with 0.75 grams and 0.3 grams react. So if we subtract 0.3 from 0.75, we get 0.45 grams is what remains at the end of the reaction. Okay? So the answer is going to be 0.45 grams. Okay. Describe how the student can obtain dry crystals of hydrated magnesium nitrate from the mixture at the end of the reaction. Okay, so remember, we've reacted all the nitric acid, so there's no nitric acid in the solution, but what we do have now left is magnesium nitrate in the product. We've got hydrogen gas, but that obviously goes up into the atmosphere, but we also have magnesium, okay? So in our final product we have magnesium because there's excess magnesium, so some of it hasn't reacted, but we also have the substance we want, which is magnesium nitrate. So somehow we need to get rid of magnesium. Now we had a question earlier about techniques we could use to remove an insoluble solid, and that's going to be filtration. So what we're going to do is we're going to filter off the excess magnesium. Okay, so if we filter off the excess magnesium, because magnesium is a solid, it's going to remain in the filter paper. The magnesium nitrate is going to go through the funnel and collect. So that then we're only going to have magnesium nitrate liquid. Okay. Now what we're going to do after that, because we want to obtain dry crystals. Okay, we want crystals. So that means we have to use crystallization. So we add magnesium nitrate, to an evaporating dish, and you heat it. You heat the solution until crystals begin to form. Okay, this is a very common question too, so it's good to learn the method. It's often worth like 5 marks, so it's good to learn the method. It's often the same every time. So you just add the solution to an evaporating dish, you heat the solution until the crystals begin to form. And then what you do after that is you switch off the heat and you allow the solution to cool. And this means that this allows crystals to grow. Okay, so the whole point of this, you want the crystals to grow. Now, once the crystals grow, you will have some magnesium nitrate obviously left in there, because not everything's going to crystallize. So what you want to do is you want to filter the excess liquid or magnesium nitrate. You want to filter the excess magnesium nitrate to obtain the crystals. Then you want to, because normally they ask for pure or dry crystals. They haven't mentioned pure here, but I'm going to state the steps anyway, because in other questions they do. So what you have to do afterwards is, once you've obtained the crystals, you wash the crystals in pure water. Then you dry the crystals in a warm oven, and in that way you get your pure dry crystals of magnesium nitrate. So that's the process. Okay, cool. The student repeats the experiment and records the volume of hydrogen gas collected. The graph shows the student's results. Use the graph to calculate the rate of reaction in centimeters cubed per second at t equals 40 seconds. Show you're working on the graph. Okay, so whenever they want you to calculate the rate of a reaction, so they want you to calculate the rate of reaction at a particular time, so in this case t equals 40 seconds, what you need to do is you need to draw a tangent at t equals 40. So I've already done that on here, but you draw a tangent at t equals 40, and what you need to do is find the gradient, and that's how you find the rate of reaction. Now, when you draw a tangent and you draw a triangle to work out the gradient, you need to make sure the triangle is quite big, like the size I've drawn. Not a minute triangle like this, okay? That's not enough to find the gradient. It has to be quite a large triangle, because you can get marks deducted for that. So you draw a tangent at t equals 40 seconds, and now you need to work out the gradient of that tangent. So gradient is going to be change in y over change in x. So obviously it's going to be hard to get a very accurate result, but they give you quite a wide range of values that your gradient can fall in. So change in y is 250 minus 150. And change in x is, let's see, so in my triangle, it's roughly 42, I think, 42 and 14. I'm going to go with 42 and 14, okay? That's the change in x, 42 minus 14. Now if I work that out, that's 100 divided by 28, and that will give you an answer of 3.57 centimeter cubed per second. Okay, so my rate of reaction is 3.57. Now the mark scheme says any answer between 2.75 and 3.75, so that's fine. Cool. Okay, last question, guys. This question is about hydrated compounds. Crystals of hydrated barium chloride contain water crystallization. A student uses his apparatus to remove and collect the water from some crystals. This is the student's method. Record mass of tube A when empty. Place a new sample of hydrated barium chloride crystals in tube A and record the new mass. Heat tube A, allow tube A to cool and record the mass. Repeat steps 3 and 4 until the mass recorded in step 4 is constant. And these are the results. Give a reason why the student repeats steps 3 and 4 until the mass is constant. So this is a very common question. It's called water crystallization. It's given to you in the question. And the reason why it's heated multiple times is to make sure that all the water has evaporated, because you only want barium chloride remaining. So the reason why it's heated until the mass remains constant is to ensure all the water has evaporated. That's the whole purpose of water crystallization. You want to evaporate all the water to make sure you only have crystals of barium chloride in this example. Okay, let's move on. Calculate the mass of barium chloride that forms in tube A. Okay, so the mass of barium chloride is going to be 15.75 minus 10.55, because as you can see here, this is the mass of tube A and then the final mass of tube A and barium chloride. So when you subtract this, you'll have just the mass of barium chloride remaining. So 15.75 minus 10.55. Okay, I don't know what is going on here. Let me rewrite that. 15.75 minus 10.55, and that should give you an answer of, let me work that out quickly, 5.2 grams. 5.2 grams. Calculate the mass of water lost. So that's going to be 16.65 minus 15.75, because as you can see here, this is mass of tube A and BaCl2.XH2O, so hydrated barium chloride, and this is tube A plus barium chloride. So if you subtract these two, you'll get how much water has been lost. Okay, so it's going to be 16.65 minus 15.75. And that should give you an answer of 0.9 grams. Okay. Determine the value of X in BaCl2.XH2O. Show your working. Relatively straightforward, I think. If we have, so let's just write a general equation. BaCl2.XH2O is going to turn into BaCl2. That does not look like a B. BaCl2 plus XH2O. Okay, so this is the water that's evaporating and this is the barium chloride that's left. And we've just worked out the values of these. So we've got 5.2 grams of barium chloride remaining and we've got 0.9 grams of water remaining. So what you want to do first is work out the moles of each. So the moles of barium chloride are moles of water, and you can do that by dividing by the MR. So the MR of barium chloride is 208, they've given it to you here, and the MR of water is 18. Now if you divide that, you should get the moles of barium chloride as 0.025 and the moles of water as 0.05. Now to work out X, what you need to do is you divide, it's similar to finding the empirical formula, you divide by the smallest number. Okay, so you divide both by the smallest number, which is 0.025. So that will give you 1 and this gives you 2. So what that shows is that X is 2. Okay, X is 2. So first what you do is you work out the moles of each and then you divide by the smallest number and you get the empirical, you get the mole ratio, the molar ratio, which is 1 to 2. So X is going to be 2. Describe a physical test to show that the water in tube B is pure. So this is another test that you just need to learn. To show that water is pure, what you do is you measure the boiling point of water. And if it is pure water, okay, if it is pure water, the boiling point should be 100 degrees Celsius, okay, if it is pure water. Okay, next question. A sample containing 0.02 moles of hydrated copper 2 sulfate is heated using the same apparatus. The products of this reaction are anhydrous copper 2 sulfate and water. This is the equation for the reaction. Give the meaning of the symbol. Okay, so that symbol is reversible, okay? It means that the reaction is reversible. So normally in a normal equation you have just a forward arrow, but if there's one forward and one backward, it means that it's a reversible reaction. Describe how the reaction can be used to show that a liquid contains water. Now, hydrated copper 2 sulfate is blue in colour, okay? Hydrated copper 2 sulfate is blue in colour, and normal copper 2 sulfate is white. Now, to show that something contains water, this is a chemical test. So the test that we proved before, where we measured the boiling point of water, that was a physical test. This is an example of a chemical test. And what you can do is you add water to anhydrous. This is anhydrous copper 2 sulfate because there's no water. That's anhydrous copper 2 sulfate, and this is hydrated. This is hydrated because there is water. So you can do it by adding water to anhydrous, copper 2 sulfate, and there should be a color change from white to blue, okay? Now, whenever you mention a color change, make sure you always mention the initial color and the final color. So, anhydrous copper 2 sulfate is white, as I mentioned, and hydrated copper 2 sulfate, which is what is formed when you add water, is blue in color. So there'll be a color change from white to blue. Calculate the maximum number of water molecules in tube B after the sample of hydrated copper 2 sulfate has completely reacted. 1 mole of any substance is 6 times 10 to the 23 particles, so that's Avogadro's constant. Now it's asking us to work out the maximum number of water molecules once all the hydrated copper 2 sulfate has completely reacted. So this is the hydrated copper 2 sulfate. That's the hydrated copper 2 sulfate. And once it's reacted, you can see we form 5 moles of water. So for every 1 mole of hydrated, For every 1 mole of hydrated copper 2 sulfate, we form 5 moles of water. So now we can use that molar ratio to work out the number of molecules that form, number of water molecules. So it tells us at the beginning of the question here, there's 0.02 moles of hydrated copper 2 sulfate that's being heated. Okay? Now, if there's 0.02 moles of copper 2 sulfate, hydrated copper 2 sulfate, the moles of water is going to be 0.02 times 5 because the molar ratio is 1 to 5. And that's going to give you a mole of 0.1. So 0.1 moles of water form. Okay? Now, we know it's not asking for moles. You have to read the question carefully. It's asking for the number of water molecules. And what they told us is that 1 mole of any substance is 6 times 10 to the 23 particles. So 1 mole is 6 times 10 to the 23 particles. So we need to work out how many particles is 0.1 moles. So you just do multiply by 0.1 both sides. So 0.1 multiplied by 6 times 10 to the 23 should give you an answer of 6 times 10 to the 22 particles. So the maximum number of particles that form is 6 times 10 to the 22. Okay? So that's the whole paper. I hope you guys enjoyed the video. It wasn't too tough, the paper, I think. If you have any questions, do leave it in the comment section. I'll answer them when I see it. And if you do have any requests for any papers that you would like me to solve in biology, chemistry, maths or physics, any board, I'd be happy to solve them and upload it the next day. But yeah, if you've enjoyed the video, please do consider liking it and subscribing to the channel, because I'll soon be releasing a video on how I got all 9s at my GCSE, which I hope will be very useful. So it's worth staying tuned for that. So thank you.